18.2D notes. Yesterday we dealt with how do you use the unit circle to find the values of sine, cosine, and tangent for the special angles 30, 45, 60, and everything that's coterminal to that. Today we're going to talk beyond the unit circle, but I got to do a few things to get us set up. Let's first talk about each quadrant, where it is, what's in there, what kind of signs do we have in the quadrants. We talked already about the fact that in the unit circle, cosine theta, sine theta. So every x value tells the cosine, every y value tells you the sine. Quadrant 1 goes from 0 degrees to 90 degrees. In radians, that is from 0 radians to pi over 2 radians. Let's look at the next. Let's just talk about signs while we're here. In this quadrant, quadrant 1, positive x's, positive y's. That means positive sine, positive cosine, positive sine, because this is my x on the cosine, this is my y on the sine, and tangent is y divided by x. Positive divided by positive, that will still be positive. So the second quadrant starts at 90 degrees and goes over here to the far left to 180 degrees. Now, I want you to think about this, the inequalities. They do not have actual equal marks under them like that, because if they had equal marks, you'd be saying 90 degrees was in a quadrant. 90 degrees is this borderline piece between the two quadrants. When we filled out our trig mega table, we didn't write down that 90 degrees was in quadrant 1 or in quadrant 2. We put down that it was between quadrant 1 and 2, or we put down that it was a positive part of the x-axis. Sorry, vertical, positive part of the y-axis. So we don't want those things. We do need to look at what radians match up with that. If we say 90, we're talking pi over 2. If we say 180, we're talking about pi. So, pi over 2 and just plain pi. And it certainly makes sense that where that last quadrant left off is where the new quadrant starts. So my next one will start with pi as a continuation of that. Let me do my degrees. If this one left off at 180, I'm going to start with 180 degrees. If I look at my unit circle, I can say that means I'm going from 180 degrees, which is the pi, and I already wrote down that pi, up to 270 degrees, which is my pi over 2. Pi over 2, because we already have pi over 2 way up there somewhere. Which means the next one will pick up starting with 3 pi over 2. Let's look at quadrant 4. I've been ignoring the signs. I'll come back and hit the signs. Quadrant 4 starts with 270, which is 3 pi over 2, and goes up to 360, which is 2 pi. So 270 degrees up to 360 degrees. 3 pi over 2 up to 2 pi. Let's talk about the signs in those quadrants. Here we have quadrant 2, and my x's are going left, so they're negative, but my y's are still going up, so they're positive. So my cosine is negative, My sign is positive. And if I divide with two different signs, I get a negative. Quadrant 3, my x's are going left, so they're negative. My y's are going down, so it's negative. I always like to remember positive, positive, negative, negative. Those are opposite from each other. So in my little table, I'll say negative cosine, because my x's were negative, negative sine, because my y's were negative. And if you do negative divided by negative, you get a positive. Quadrant 4, x's are going to the right, positive, y's are going down, negative. So I have positive x's, positive cosine, negative y's, negative sine. And when you divide with two different signs, you get negative. The other way to remember that is all students take calculus. In quadrant 1, they are all positive. In quadrant 2, S for students, S for sign. Only the sign is positive. Quadrant 3, T for take or T for tangent. Only the tangent is positive. Quadrant 4, C for cosine or C for calculus. Only the cosine is positive. That all students take calculus, that works for telling what's positive. Okay, right in there. If you need to pause it and look at it now, you can do that, but I didn't want you to wait for where I didn't need to do that. Okay. Yesterday we did this table. We're going to do this table again because it's a quick and easy way if you don't actually have the unit circle in front of you to figure out what's going on. I start with square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. And then simplify each of those down. Square root of 0 is 0 divided by 2 is still 0. Square root of 1 is 1 divided by 2 is 1/2. Root 2 over 2 doesn't reduce. Root 3 over 2 doesn't reduce. Square root of 4 is 2 over 2, so I just get 1 here. And then I take it in the opposite direction. 0, 1/2, root 2 over 2, root 3 over 2, and 1. Ooh, let's go back and put the degrees on the top. 0 degrees, 0 radians, same thing. If I'm looking at the special ones, I have 30, 45, 60, and 90. 45 is the same as pi over 4. I remember the 4 with a 4. 30 degrees gets a 6 on the bottom. 60 degrees gets a 3 on the bottom. My denominators are going 6, 4, 3. Next one's 2. And it always goes around the circle with the denominators in that order. Let's look at the tangent section. And I know I said this before, but then we didn't have any tangents on yesterday's assignment. The tangent is always the sine divided by the cosine. The sine is my y, the cosine is my x, the tangent is my y over x. Or you can write sine theta over cosine theta. I expect to see work for tangent every time they ask you for the tangent. But let's see what we have. We have 0 over 1. We have 1/2 divided by root 3 over 2. We have root 2 over 2 divided by root 2 over 2. We have root 3 over 2 divided by 1/2. We have 1 divided by 0. Zero over 1, and that's 0. Remember the little shortcut I said yesterday? If you're dividing two fractions and they have the same denominator, wipe out the denominator. Think about this one as 1 over root 3. Can't have root 3 on the bottom. Root 3, root 3. This turns into root 3 over 3. Kind of running off the edge on that one. But that's what that answer is. The next one, I could wipe out the 2's on the bottom, which just leaves me root 2 over root 2. Or I could look at it in the first place and say, wait a minute, anything divided by itself is going to be 1. I still want to see this fraction. You don't need to show work to reduce it. The next one, if I wipe out my 2's, I get root 3 over 1, which is just root 3. The last one, remember that when you have 0 on the bottom, you're undefined. Another way to think about tangent is it's kind of like the slope of the angle. If I look at this and I'm trying to talk about 90 degrees, do you remember that's a line with a undefined slope, vertical line? If I look at 0 degrees, that has a 0 slope. It's a little harder to read the slope on the others, but you can think of it that way if you're forgetting which one's 0 and which one's undefined. Okay, now let's start using that stuff. Here we go. Some examples. Yesterday, I only gave you examples in the notes that were angles between 0 and 360, or between 0 and 2 pi. Now I'm doing ones that are beyond that. I'm going to find a coterminal angle. In other words, get it down to something normal, and then you can actually work with it. So coterminal angle means I need to add and subtract a full circle. In degrees, that means I'm going to add and subtract 360. 765, way too big. Minus 360 degrees gives me 405 degrees. Still too big. Let's subtract another 360 degrees. 45 degrees. So, we've got 45 degrees. I didn't even draw my unit circle here, but we're going to just take a quick sketch and look at that. 45 degrees is over here. That's quadrant 1. Reference angle. If you're at 45 degrees, how far is it to the nearest part of the x-axis? 45 degrees. Remember that at that point the sine is the y, the cosine is the x, tangent is the y over the x. I also know that when I'm in quadrant 1, all my signs are going to be positive, so I don't have to worry about putting any negatives in there. So I'm thinking 45 degrees. I'm thinking I'm going to look at this table. I'm going to look at all those numbers right there. The sine, hey, if you know 45 degrees is the one that's in the exact center, it's the one where the sine and the cosine are the same. Maybe sines would be different. But it's the root 2 over 2, root 2 over 2. I always remember that the one that's in the exact center has the same x, the same y, the same sine, the same cosine, the same number on the top and the same number on the bottom, except of course the top has a radical. Just a way to remember it. And the tangent would be root 2 over 2 divided by root 2 over 2. Yes, I want to see that. But I don't think you need any work to reduce that, do you? Let's look at negative 150 degrees. This time, 150 is on the unit circle, but negative 150 is not on the unit circle. So I need to adjust it by doing plus 360 degrees. 210 degrees. Then I have to think about what quadrant that's in. If this is 0 and 180 and 360, is it closer to 180 or closer to 360? I don't know, but it's out here somewhere, because I also know that's 270. Helps to have those 4 parts memorized. So I know that it's over here in quadrant 3. I know that in quadrant 3, I've got negative, negative. Reference angle, you have to say, is it closer to 0 or 180 or 360? It's closer to 180. So I'm going to say, what is 210 minus 180 tells me 30 degrees. My reference angle, 30 degrees. But because I know I'm in quadrant 3, negative, negative, or think this way, all students take calculus. In this section, only the tangent ends up positive. Okay, 30 degrees. So on my table, I'm going to look at the 30 degree line right there. And I'm going to say my sine is 1/2. My cosine, root 3 over 2. My tangent, divide those. Negative 1/2 divided by negative root 3 over 2. Because it's always the sine divided by the cosine. Shortcut, wipe those 2's out. Maybe also wipe out those negatives. I have 1 over root 3. I'm not supposed to leave a radical on the bottom. Root 3, answer root 3 over root 9, which is plane 3. There's my tangent. Okay, let's try some of those in radians. I have 3 examples in radians, because for some people the radians are harder, and I thought we should do a few more. 15 pi over 4. I really think that with the radian ones, a sketch will help you. We did some sketches there too, just so I could show you what I was talking about. But I wouldn't have bothered for myself. For these, even for myself, I think about a sketch. So I'm saying a really rough sketch. This is pi. This is 0. Because I have a 4 on the bottom, I'm calling this 4 pi over 4. Over here for the 2 pi, I'm keeping a 4 on the bottom, but 2 times 4 is 8 up top. So 15 pi over 4 is bigger than a full circle. Let's get rid of the full circle and see what we have left. 15 minus 8 is 7 pi over 4. And then I'm going to take a rough idea of where is that on the graph. 4 pi over 4, 8 pi over 4, it's close. 7 pi over 4 is closer to this. So I'm just throw it over here. If somebody asked you to draw the measurement of that angle, that would not be a good enough picture. It's just a sketch so we can get an idea of where we are. I would say we are in quadrant 4. And let's think about our reference angle. Since this looks like it's closer to 8 pi over 4, I'm going to do 8 pi over 4 minus 7 pi over 4 equals pi over 4 reference angle. But if you wanted to instead use the shortcut to find my reference angle, the picture helped me figure out my quadrant, but I could just say shortcut for reference angle. Bottom of the fraction is 4, pi over 4. Bottom of the fraction is 6, reference angle, pi over 6. Bottom of the fraction is 2, reference angle, pi over 2. You're allowed to take that shortcut. that won't work if the bottom of the fraction is not one of the basic 2, 4, 6, oops, skip to 3. 2, 3, 4, there is no 5 and a 6. It won't work for anything else, but guess what? When we're doing sine, cosine, tangent, they're not going to ask you something with a 9 on the bottom or a 12 on the bottom or a 62 on the bottom, because we don't know how to find sine, cosine, tangent for those. These are the ones we know. We can just call it that. Let's finish off this problem before I go back and work on those others. Because I'm in quadrant 4, I know that my x's are going in the positive direction to the right, and my y's are going down, so they're negative. That means that my x is positive, my y is negative, and when I divide them, I will get a negative. Or again, I can say all students take calculus. In this quadrant, only cosine gets to be positive. Whichever way is easier for you to remember it. So now I'm trying to say my reference angle is pi over 4. I'm going to go up to my table and look at the pi over 4 section. Or if you can remember that pi over 4 is the same as 45, it's the one that's in the middle. The one that's in the middle has the same answer for sine and cosine, except you can see one's positive and one's negative. It has that 2 on the top and the bottom, because it's right in the middle. It's matching. Everything's the same. Of course, it has to be root 2, not just plain 2. And then when I do my tangent, I'm doing root 2 over 2 divided by root 2 over 2. And the sine one happens to be negative, which just means my answer is going to be negative. And anything divided by itself, I get negative 1. There we have our sine, our cosine, and our tangent. I think that on my last video, one of those, I forgot to write down the negative sign. So when you look at the link in the School Loop assignment, there's a disclaimer next to it saying, I've made a mistake. Read those things. Okay, here we go with negative 5 pi over 6. It's negative, so it's outside of the normal unit circle. I'm going to think about, here's pi, because this has a 6, I call it 6 pi over 6. And then over here, pi over 6, but 2 times 6 puts a 12 on top. So it's negative, and I don't want it to be negative. I want it to be something normal. So I'm going to say negative 5 pi over 6 plus a full circle puts me at 7 pi over 6. Notice when I'm doing these sketches, I say these would not be adequate if they asked you to draw the angle. Well, I'm not worrying about drawing in the arcs. I'm not worrying about making them in a perfect position. Obviously, if I just subtracted a full circle, there'd be an extra full rotation around before we even started thinking about this. But 7 pi over 6 is closer to 6 than it is to 12. So it's over here somewhere. It is in quadrant 3. And in quadrant 3, my signs are x is going left, so they're negative, y is going down, so it's negative. So my x's are negative, my y's are negative. When I divide them, this is going to turn positive. In my workspace, I'm going to show you with the negatives. But even if I didn't, knowing in advance it's positive, that's good. So I'm looking at the pi over 6 column. I'm looking at this column. My sine is 1/2. My cosine, root 3 over 2. My tangent, divide those two things. So negative 1/2 divided by negative root 3 over 2 And I don't usually write those slanted fraction bars, but in this case, where we're trying to fit a fraction over a fraction, I often do. Wipe out the 2's so that I have negative 1 over negative root 3. In fact, negative divided by negative is positive. I don't want to end up with radicals on the bottom, so I have to multiply root 3 over root 3 so that I get tangent theta equals 1 root 3, and root 3 times root 3 is just 3. There's my tangent. And notice that negative divided by negative turned out positive as we said it should. Okay, one more of these. I didn't even draw a picture that time to see what's going on. Oh yes, I did draw a picture. I was going to say, I didn't need my picture to figure out the reference angle, though, did I? Okay, let's look at this one. Again, I want to think about the measurements. This is pi. Because that has a 2 on the bottom, I'm calling it 2 pi over 2. This is pi over 2, but 2 times 2 puts a 4 up on top of that one. This is more than a full circle. 11 pi over 2. Take away a full circle. 7 pi over 2. Still bigger than a full circle. Let's do that again. 7 pi over 2, take away a full circle, 3 pi over 2. So, that's the location of it, and the location of it is actually straight down here. Halfway between 2 halves and 4 halves would be my 3 halves. If I really needed to draw this, I would say full circle. Another full circle, and then I can think about going to where I need to be. Yeah, that is not required on here. What quadrant am I in? I'm not really in a quadrant, am I? I am halfway between 3 and 4, and I could start by saying between quadrant 3 and 4. Putting this on the top because that's not the short way to do it. Between 3 and 4. The short way to do it is say I'm on the negative part of the y-axis. And I think that one of these that pointed straight down like this was the one where I messed up on the last video. So I have a hard time saying all students take calculus when I'm not really in a quadrant. So I have to think instead about sideways 0, down 1. If you have your unit circle, you'd already know that, but I have to think about that. So I'm going to say have I written it anywhere yet? Cosine theta is my x, my sine theta is my y. So I can look at 0 is my x, my cosine, y is my sine, -1, and when I go to divide this thing, I have the sine divided by the cosine, which is undefined. Okay. Then we have some other problems that don't even deal with a unit circle. This time they did not tell me it was a unit circle. Because usually I just write them as we go, but my writing on using my stylus on my iPad is not that neat, so I wrote them out in advance. So draw a right triangle with the right angle on the x-axis, find the side lengths. So if I'm looking at the sides of the shape here, this side is going left to right. It is my square root 11. This side is going up and down. It's my negative 5. Now, truthfully, you can't have a negative for a length of a side if you're making a triangle, but I like to put it in anyway so that we'll have it when we get to the end. And let's think about what we need for sine, cosine, tangent. I'm going to save this space for my answers. I'm going to make this my workspace. If we think SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. In these problems, we always make our theta angle be at 0, 0. And if theta is at 0, 0, then we always have the side opposite from theta is our y value. The side adjacent to theta is always our x value. So hey, it kind of looks like what we were doing with the unit circle. It looks like sine is y, cosine is x, tangent is y over x. But it's not totally true in this case, because in this case, we don't have a hypotenuse of 1 like we did in a unit circle. That's what a definition of a unit circle is. Unit means a single item. A unit circle has a radius of 1, and every one of those triangles has 1 for its hypotenuse. In this case, we have a hypotenuse that we have to work out ourselves. So basically I'm going to think a squared plus b squared equals c squared, but I'm going to write it as x squared plus y squared equals c squared. In this case, my x is the square root of 11. The y is the negative 5. Now, some teachers take off that negative right now. And certainly you're allowed to do that if you want to. Some teachers change that negative right there into a positive. I usually don't bother. But there is a problem with that, the way it is. If I do square root, let's just do this one because that's what I'm talking about. Negative 5 times negative 5. I hope you know a negative times a negative is always a positive. But some people put it in their calculators, and if they put it in their calculators without parentheses, the calculator's going to tell you negative 25, which is all fine. You'll probably notice that, unless you try to put the whole left-hand side in your calculator at once. Square root of 11 times square root of 11 is the square root of 121. It's just 11. So 11 plus 25, 36 equals my c squared. And of course I have to take the square root. And for my c value, I don't have to worry about doing the negative, so I'll just do 6. I don't need to worry about plus minus. So if I'm trying to work this problem out, I'm going to come up here and I'm going to say the sine is the y value, and the c we just worked out to be 6. So the answer for sine theta, negative 5 over 6. Some people don't worry about the negative till the end, but based on its quadrant, I know that only cosine gets to be positive. Everything else gets to be negative. It's going to work out that way. Cosine is my x value, which was square root of 11 over 6. Nothing I can do to simplify that. tangent is the y value, which was negative 5, over the x value, which is square root of 11. Now here we have issues, because we're not allowed to leave a radical on the bottom of the fraction. Multiply top and bottom by root 11, so I get negative 5 square root 11 over root 11 times root 11 is plain 11. And I'll move that over to my answer space. Negative 5 root 11 over 11. Okay, there are, I think, just maybe 4 of that type at the end of your assignment. But remember that when it's not a unit circle, I can't just use sine as y. I have to use y over the hypotenuse. I can't just use cosine as x. I have to use cosine over the hypotenuse, which means I'm going to have to do this and figure out the hypotenuse myself. It's always theta angle at 0, 0, so it will always be y is my opposite and x is my adjacent. But you still have to think about the hypotenuse before you can work that out. Okay, enough of that. I will definitely come back and do some of these for you. Probably I will wait until after the Zoom meeting so I can see if there are people who have specific problems they want worked out for me.